Hello friends, now we see the problem number 8, which is also based on principle of mathematical induction of chapter method of induction and binomial theorem. The problem number 8 is we have to prove that phi plus phi square plus phi cube plus dot dot plus phi raised n is equal to phi upon 4 in bracket phi raised n minus 1. So this result is a true for all n belongs to set of natural number. Now let's see the solution. First of all, we denote this entire problem as a PA. So let P of n equivalent to phi plus phi square plus phi cube plus phi raised n that equal to phi upon 4 in bracket phi raised n minus 1 for all n belongs to set of natural number. Now we consider the step number 1. Put n equal to 1. Now left hand side is equal to, we have to consider the first term on LHS of statement PA, and that is phi. So it means here left hand side is equal to, we get phi. Now we consider the right hand side, that equal to phi upon 4 in bracket phi raised n minus 1. In this equation, we have to put n equal to 1. So the next step will be phi upon 4 in bracket phi raised 1 minus 1. That equal to phi upon 4 in bracket. Now phi raised 1 gives phi and phi minus 1 we get 4. Here we 4 cancel from numerator and denominator. So we get is equal to phi. So in this way we get left hand side is equal to right hand side. It means P of 1 is a true. That is P of n is a true for n equal to 1. Now we consider the step number 2. Let us assume that the P of n is a true for n equal to k. That is phi plus phi square plus phi cube dot dot plus phi raised k is equal to phi upon 4 in bracket phi raised k minus 1. Now let us this denote as a equation number 1. Now we consider the step number 3. In step number 3, we have to prove that the P of n is a true for n equal to k plus 1. that is 5 plus 5 square plus 5 cube plus 5 raised k plus 1 is equal to 5 upon 4 in bracket 5 raised k plus 1 minus 1. Now we consider LHS. So that equal to 5 plus 5 square plus 5 cube going on up to plus 5 raised k plus 1. That equal to 5 plus 5 square plus 5 cube plus going on, and the last term is 5 raised k plus 1. The second last term is here 5 raised k. Now here we make it bracket from 5 to 5 raised k. By using equation 1, that 5 plus 5 square plus 5 cube plus dot dot plus 5 raised k is equal to 5 upon 4 in bracket 5 raised k minus 1. So the next step will be 5 upon 4 in bracket 5 raised k minus 1 and then plus 5 raised k plus 1 we write as it is. Now here if you open the brackets, then we have 5 upon 4 into 5 raised k, so that gives us 5 raised k plus 1 upon 4, then minus 5 upon 4 into 1, so that is 5 upon 4, and then again we have plus 5 raised k plus 1 upon 1. Now from first and last term we take 5 raised k plus 1 common, so the next step will be 5 raised k plus 1 in bracket we have 1 upon 4 plus 1 upon 1, and the middle term minus 5 upon 4 we write as it is. So that gives us 5 raised k plus 1 we write as it is in bracket. Since the denominator are different, so we go for cross multiply. So on cross multiplying we get 1 into 1 1 plus 4 into 1 4 upon 4 into 1 we get 4, and the second term minus 5 upon 4 we write as it is. So from this we get now 4 plus 1, that gives us 5 upon 4 into 5 raised k plus 1 and minus 5 upon 4 we write as it is. From these two we take 5 upon 4 common, so in bracket we have 5 raised k plus 1 minus 1, and that is nothing but our RHS. So in this way we prove P of n is a true for n equal to k plus 1. Therefore, by principle of mathematical induction, P of n is a true for all n belongs to set of natural number. This is a required solution for the given problem. Thank you.